All right, so you'll have a little bit more training wheels than this on the exam because you'll have the little framework of the tree diagram set up. But theoretically, I've done some multiple choice questions in the past where you've had to do the entire tree sort of on your own. So exercise 6 is a good example of that. So reading through exercise 6, looks like we have two different outcomes that we're interested in. We have something about convicted, and we have our keyword of given, guilt. And then they gave us a percentage here, so we wanted to translate that. Conviction, given that they're guilty, right? Whatever's behind the given goes behind the line, is 95%. And the probability that a defendant is acquitted, given innocence. So the probability of acquitted, given innocent, and again, you could use G complement and C complement if you want, is 97%. So basically, these are our correct convictions and our correct acquittal rates. And then we've got a final piece here. Suppose that 80% of all defendants are truly guilty. Nothing here about being convicted or acquitted. So the probability of guilt for a defendant is 80%. And then it asks us to draw a tree diagram. So even if it didn't say draw a tree diagram, the fact that we have some givens tells us that a tree would probably help, because that's what our trees are going to work well with. So we're going to start with all our defendants. And there's two ways that this could get split. It could get split based on what the decision is, conviction or acquittal, or whether they're originally guilty or innocent. And remember, the thing by itself is going to tell us how our first split should go, because it starts with the probabilities. So we have two possibilities for our defendants. They're either guilty or they're innocent. And the probability that they are guilty, well, that's 80%. And the probability that they're innocent, since those are complements, has got to be 20%. And then we're going to split this up again. Now, if you're somebody who has trouble with the idea of these percentages and trying to understand what the heck the tree is doing, one thing you can do is sort of think about starting with, say, 1,000 defendants. If 80% of them are guilty, that means 800 are guilty and 200 are innocent. So sometimes seeing the numbers rather than the probabilities makes this a little bit easier to actually sort of process what's going on. So again, from the guilty, we have two options. We can either convict them, make the correct decision, or we can acquit that person, make an incorrect decision. And as I translated, we know that they are guilty, so that's what's going to go behind the line in our notation. And we have this rate. We know 95% of the time, if they're guilty, that they're convicted, which means 5% of the time we must make the wrong decision and let them go free. Now again, you could do this with that 800. Now at 95% of 80%, which seems kind of weird, is a little bit friendlier for a lot of students. Now we could actually see that this is 760 of the people, while the remaining 40 are acquitted. And this just sort of lets you see these numbers. And then you could go back to percents at the end. Now on the test, I do need to see the actual probabilities because that's what I ask for, but just letting you know that if you're having any trouble sort of wrapping your head around what the heck this tree is doing, the numbers can help. So for the innocent, 200 innocent people, or the 20% that are innocent, again, they have the same two options, convict or acquit. And we could write those in with our notation, right? So we know they're innocent, so it's a probability we acquit. What's a probability we convict? And they gave us acquit given innocent. So we got this 97% of the time we make the correct decision with the innocent defendants, which means 3% of the time we do not. And again, we could go ahead and actually split up our 200 people. 3% of 200 is 6, and 97% is 194. So we can actually see where all of these 1,000 defendants end up. And this, like I said, makes more sense for people as to why we're multiplying to get to the final piece. So if we multiply down these rows, we're going to get the probability of C and G, the probability of A and G, the probability of I and C. It doesn't matter what order we write these in. And the probability of I and A. I wrote them in different orders for the two, but it doesn't matter because and is and regardless. And so like I said, with the numbers here, I can actually see that if I'm divided by that 1,000 exactly what my percents would be, or my probabilities would be. But again, to find these, I would just multiply the 80 with the 95, or the 0.8 with the 0.95. But same idea of what we're doing here with the numbers to get that value. So the one thing you didn't see in exercise 4, but you did see in that worksheet, in that when Professor Steele went over exercise 5, is the questions that come after this. So like I said on the test, you're probably going to see something similar to this. You're going to have at least, you're going to have at least 2 questions that follow the warm and fuzzy question, the warm and fuzzy tree diagram. So this is where it's going to make your life a lot easier if you've set up your table, which is why I made you do that on the worksheet. And so our table, we have guilty or innocent, right, as our 2 options there, and convicted or acquitted as our 2 options on the other side, because we want everything to overlap so we can get all of our ands on the table. So CNG 0.70 or 0.760, ANG 0.040. If we add those back up, we get our 80% that are guilty, innocent that get convicted, innocent that get acquitted. And again, you could actually do these with the numbers, especially for the fact that you're just using this as a help. If you wanted to use the numbers, you could. There's absolutely nothing wrong with that. Like I said, the only way I would dock you for the numbers is in the tree, because I do want to see probability notation there. But you can do them as like I did as help if you'd like. So once you got your table and your tree done, you're going to see the different questions you get asked here. In this case, I've given you 4. Basically, I could ask you 3 or 4 different things. I could ask you for the and probability, the or probability, something alone, right? What we call the marginal. I'll call that the one where there's only one. And our given, right? Our conditional. And 2 of these are guaranteed for you to see on the test. The marginal and the given, I always ask about. That's because when we split this up into innocent and guilty, we could have split this up into the other way, either convicted or acquitted. And that's always a question I ask. And then for the given, we had all these givens in that direction, but I also like to see the givens in the other direction. Like if somebody's in jail, what's the probability they're actually guilty? So those givens in the other direction are always something I ask for, and the marginals at the other side are also something I always ask for. So as we work through this, the first question says, what is the probability a defendant is acquitted? Nothing here about guilt or innocence. So we just have probability of A. And like I said, it's super easy if we have our table, because we're able to just pull this off. If you're doing this from the actual tree, you're going to have to add together these 2 acquitted pieces. And if you're doing it from the tree, remember to make yourself a mental note. We're never going to use anything in these sections here, because that is, especially I see a lot of students do that, they add these 2 together and they'll give me like 102%, which is insane. So don't do that. Use these this last column, or just make your table and you won't have any mistakes. Second question here says the probability that a defendant is convicted. Nothing again about guilt or innocence, so we're doing convicted. And again, I can grab that straight off the table, or I could recognize that these 2 things are complements and do 1 minus. Okay. And then, so like I said, one of these is guaranteed to be on the test. The other one's guaranteed to be on the test, I'll just jump to it, is the last one. There's our given in the other direction. So given convicted, what's probability they're innocent? So we know they were convicted. What's the probability they're innocent? Right, sort of the worst case scenario, that we have a guilty person behind, an innocent person behind bars. And remember, for your givens, you can grab this off the formula sheet. This is and divided by what we know. So in this case, we've got 0.006 from our table, right? We know they've been convicted. What's the probability they're innocent? And 0.766. And again, with the numbers, this is even more obvious, because we go, okay, they're one of the 766 people we convicted. What's the chance that they're one of the 6 innocent people in that group? So let me finish that. Looks like this is 0.0078. So less than a 1% chance of this. And then the last one, this is not guaranteed. This is a possibility. The or is more likely than the and, because the and is just any of the ends. But our or here, it says, what is the probability a defendant is guilty or convicted? So this is another one where we'll have to use our formulas. This is the probability of guilt plus the probability of convicted minus the piece that we counted twice, the and of for guilty and convicted. And again, we can see this on our actual contingency table. Convicted or guilty are these two, and that would have us double counting that 760. So convicted, probability of guilty is 80%, probability convicted 76.6%, minus the 76 that overlap gives us 806. So anyways, like I said, these two are guaranteed, and then an or is possible for this question on the test. And the easiest way to make sure you don't make any mistakes is to create that contingency table.